Hey guys, this is 3.2 part 1. We're going to be looking at domain and range of functions. So as you know, the domain is talking about the x values of a function. Specifically, it's going to be the x values for which the function is defined. And what that means is if you look at the graph so for example, if you look at the graph, there's going to be a y value at that x value for the domain. Also, it means you could plug that number into the function and you would get a real y value as your output. Okay, so let's look at how we can find the domain of functions using these steps. Step 1, identify the input values. So that's just saying I'm looking at my function, for example, on number 1, and I'm saying, okay, I'm inputting an x here. We're trying to figure out what x values I can input into this function, and the function is defined. So what's happening to the x is it's going to be first squared, then multiplied by 4, and then subtract 9 from that value. On number 2, you would say the input value is again x, and x is going to be subtracted by 5. Subtract 5 from x, and then they're going to divide by 3 minus that x value. Okay, so just noticing where those x's are in the function and what's happening to them. So step 2, and this is just very, very important in identifying what the domain of a function is. Identify any restrictions on the input and exclude those values from the domain. Okay, and then we've got these two ways that an input value can be excluded from the domain. So A, if there's a fraction, so say I've got like 2 over x. F of x equals okay, so if you've got a fraction like that as your function and you have an x in the denominator, a variable in the denominator, well, you can't divide by 0, right? So that x could not be 0. So you would have to exclude that from the domain. That is an example of a restriction. So A is just talking about anything that would make you divide by 0. So to figure out those numbers, to figure out what numbers would make you divide by 0, you're going to set the denominator equal to 0 and solve for x because we can't divide by 0. So you need to exclude anything that would make you divide by 0 there. All right, and then B, if there is an even root. So, that's supposed to say set. Set the radicand, which is the expression underneath the radical, greater than or equal to 0 and solve for x. Why? So think about an even root. If you have an even root in your function, something like that, why does the x minus 2 have to be greater than or equal to 0? Well, what if it's less than 0? So that means it's negative. If x minus 2 is negative, then I'm taking the square root of a negative number, and that would give me an imaginary y value. So why? Because it would give you an imaginary y value. Taking the even root so that's a square root, 4th root, 6th root, any even root of a negative number would produce an imaginary y value. Okay, and good luck graphing that, right? An imaginary y value on our xy plane, not going to work. All right, and then step 3, we're going to write that in interval notation if possible. So let's look at number 1. So this one is a quadratic. This function is a quadratic function, which means if I graphed it, it would look like a parabola. Do I see any, so looking at step 2, do I see any fractions? No. Is there an even root? No, there's an even exponent, but that's not a root. There's no radical. So your domain is going to be all real numbers. If there's nothing that you need to restrict in step 2, your domain is all real numbers. So on any polynomial, you're going to get that, all real numbers. All right, number 2. We've got a fraction here for sure. So we need to, it says to set your denominator equal to 0 and solve for x. So I would just add that x over. So x equals 3 would make the denominator equal 0, right? If I had 3 minus 3, the denominator would be 0, can't divide by 0. Therefore, you need to exclude 3 from the domain. Personally, when I do this, I like to say it cannot equal 0, right? 3 minus x cannot equal 0, therefore x cannot equal 3. And then I know I need to exclude that from my domain. So x can be anything except 3. So let's write that in interval notation. It can be anything, so negative infinity all the way up to 3. Parentheses, because we cannot include the 3. Parentheses, start at 3 again and go to infinity. So if you're wondering what just happened, let me show you kind of on a number line what just happened. So it could be any number except 3. So it's like we have an open circle at 3 because it can be anything except 3. That means it can be 3.1. It could be 2.9, which is right before the 3. So it can be anything except the 3. So that's negative infinity 3, parentheses because an open circle, and then 3 to infinity. So that would be your domain, just excluding the 3. Okay, number 3. All right, so we have a fraction again on this one. So remember your denominator, which is x squared minus 9, cannot equal 0. You can put equal 0 or cannot equal 0. I like cannot equal 0 again because it reminds me that x cannot equal that value. And why? Remember, it's because those values would make you divide by 0 when you plug them back in. You can't divide by 0. Okay, so let's factor this, or actually let's use the square root property, right? So we'll add the 9 to both sides. And we'll take the square root of both sides. Plus or minus x equals plus or minus 3. You could have gotten that same exact answer by factoring. This is the difference of squares. So that would be x squared minus 9 cannot equal 0. X plus 3 times x minus 3 cannot equal 0. I'm going to put an or here, so you can do it either way. And so x plus 3 cannot equal 0, which means x cannot equal negative 3. X minus 3 cannot equal 0. X cannot equal 3. So either way, you get positive and negative 3. And those are the only two things that you need to exclude from your domain. There's no radicals. You don't need to do anything with the numerator. just the denominator. You can't divide by 0. Okay, so let's write that in interval notation. Again, anything except -3 and +3. So if you need to see that on a number line, you can. Let's do this. So -3, 3. Open circles at both because we just cannot include those numbers, but we can have anything else. Okay, so writing that would be -infinity up to -3, union 3 to infinity. Oh, sorry, messed up there. Okay, union, I need to start at the -3 again to include that in between part right here, in between -3 and +3. So start at -3 again, all the way to 3. And then my last section is going to be from 3 to infinity. There we go. So that's how you would write that in interval notation. All right, number 4. Okay, so this time we have a radical and it is an even radical. So because we have an even root, we have to look at step B, part B. If there is an even root, set the radicand, which is the expression underneath the radical, greater than or equal to 0 and solve for x. Okay, so basically we need 10 minus 2x to be greater than or equal to 0 so that you're not taking the square root of a negative number, right? We can't take the square root of a negative, so it needs to be positive, whatever's underneath the radical. Must be positive. Otherwise you get imaginary y values. All right, so let's solve this for x. So I can add the 2x to the other side. Divide by 2. Okay, so that's, I'm going to flip it around. X is less than or equal to 5. So that is a restriction on x. X must be less than or equal to 5 in order for that to not give you imaginary solutions, imaginary y values, right? So just to check that, if you plug in a number less than 5, so let's say I plug in 0, that's less than 5. 10 minus 2 times 0 is 10. And we can take the square root of 10, that would be a real number. However, if I plug in a number not less than 5, so 10. So 10 minus 2 times 10, that would be -10. And the square root of -10 would be imaginary. That's why we can't have numbers that are greater than 5 here. But what happens if you actually plug in 5? We're probably wondering that. So we're wondering why it can equal 5. Well, that would actually equal 0. And you can take the square root of 0. It's just 0. We are only worried about getting imaginary y values. We don't want that. So what's underneath the radical has to be greater than, so positive, or equal to 0. Okay, so that's the only restriction you have on x. If you want to see that on a number line to help you write that in interval notation, just plot that 5 less than or equal to, be right here to the left. So -infinity to 5, square bracket. Square bracket on the 5 because we can equal 5, we just have to be less than or equal to that. All right, number 5. All right, on number 5, I've got a cube root. All right, that's not an even root. I can take the cube root of a negative number. Okay, so that doesn't give us any restrictions. Okay, you can take the cube root of any number, including negative numbers, so that doesn't give you any restrictions. So this one's going to be negative infinity to positive infinity, just like the polynomial on number 1. It's only even roots that give you those restrictions. All right, number 6. So wow, this one, we've got a lot going on here. So let's take it one step at a time. So first of all, notice you've got x's in the denominator, and they're taking the 4th root of for that radical. So step 2, a says that your denominator cannot equal 0. So that's the 4th root of x squared plus 8x cannot equal 0. Okay, and then b says that what's underneath the radical, which is x squared plus 8x, needs to be positive, greater than or equal to 0. All right, so let's solve both of those and see what happens. So x squared plus 8x cannot equal, well, I raise both sides to the power of 4 to get rid of the 4th root. Well, 0 to the 4. 0 times 0 times 0 times 0 is just 0. Okay, and continue solving for x. So you need to factor the x out here. So that's x cannot equal 0 and x cannot equal negative 8. Okay, so those both have to be restricted from your domain. Now let's look at b. So again, you need to factor that. So that's x must be greater than or equal to 0, and x plus 8 has to be greater than or equal to 0, which, solve that, x is greater than or equal to negative 8. Okay, so these are both restrictions. Then I've got this restriction and this restriction, but let's look at these two, because we have two greater thans here. So I'm thinking one of them is probably unnecessary. I'm going to put it on a number line just so we can visualize. Negative 8, 0. If I graph that, greater than or equal to 0, that's going to be right here. Greater than or equal to negative 8, right here. Well, it has to be both, right? Either one of those would cause me to have an imaginary, anything less than either of those would cause me to have an imaginary y value. So we need to take this one. It's called the most restrictive. You need to take the most restrictive interval there. So that would be x is greater than or equal to 0. Okay, so again, it's because if you're greater than 0, you're already greater than negative 8, right? If I am a number that is greater than 0, I'm already greater than negative 8, so that is kind of irrelevant. This one becomes irrelevant because the 0 takes care of it. Okay, so let's put all of that together. I'm going to draw another number line. So I've got some important numbers here, negative 8, 0. So I can't equal either of those two, so I'm going to put open circles there. And then also, I have to be greater than or equal to 0, but I can't equal 0, so I'm going to leave that open. That 0 is restricted from our domain, so I'm going to leave that open circle. All right, so let's see what else we've got. That's it. That's all the numbers you can be, right? Because I can't be here from negative 8 to 0, because that would be not greater than 0. And it has to be greater than 0. I can't be over here less than -8 because, again, I have to be greater than or equal to 0, which is, oh, sorry, you can't be -8 because you have to be greater than or equal to 0. So that gets taken out by the fact that you have to be greater than or equal to 0. Okay, so we're going to have parentheses 0 to infinity. And that's it. Just from 0 to infinity, not including the 0 because of that. All right, and let's look at page 2. So these 4 problems, we're going to be finding the domain from a graph, actually the domain and range. I'm sure that you remember this from some previous math classes, so hopefully this is a refresher. All right, first of all, domain, remember, is all of the x values. So looking at this example, they have drawn this arrow here denoting, hey, these are all of the x values. It's the x values start here at -5, and then the graph continues on until it goes down, and then it goes down forever. So because of that arrow at the bottom, your domain is also going to go on forever to positive infinity. So if you wanted to, you could take your pencil, lay it flat on your paper, and kind of drag it from left to right just to see where those x values are. However, if you ever see an arrow, that means it's going to go on forever, so that would be infinity. So -5 all the way to infinity for this one. Square bracket because we have a closed circle there. And keep in mind that any point on a line is automatically a closed circle. These are all, a line is made up of infinitely many closed circles, or points, technically. A line is made up of infinitely many points, so those would all be square brackets unless there's an arrow or an open circle. All right, let's look at the range. So going from bottom to top, right? Because for interval notation, you need to go from least to greatest. So the lowest y value, well, it's an arrow down here. So that's going to go on to -infinity. And then the highest y value, it goes all the way up to 5. Oops, -infinity, all the way up to 5. Square bracket because we have a point there. All right, number 2. So domain going from left to right so that we get those from least to greatest. My leftmost point right here is at -3. X equals -3. And it's an open circle, so I need to put a parentheses there. My rightmost point right here is at 1. And it's a closed circle, so I'll use a square bracket. Now going from bottom to top for the range, the lowest points that I see are these two. They're both at -4. So the lowest y value is -4, and that'll be a square bracket because we have points there. Now, the highest y value. Well, I've got both of these points which are at the same y value, 0. But since this one has, the point at 0, 0, because it's a point and not an open circle, that value 0 is included in the range. Because I have a point that has 0 as the y value, that will be included in the range. It overrides that point at -3, 0, which is an open circle. Okay, so the 0 is included because of this point at 0, 0. All right, let's look at this one. This is a rational function, the domain. So going from left to right, I've got the leftmost point, and you're looking at the blue one. The red lines are actually called asymptotes. The function is actually the blue one, so we're looking at the blue one here. So domain goes from -infinity all the way up to, at the asymptote, there is no point. Both of these blue lines, they go up to the red line, but they don't actually touch it or cross it. So for that reason, you're going to have to exclude 5 from the domain. So up to 5, parentheses, union, 5, and then it goes on. So it starts back at really close to 5 here on the second blue curve, and then it goes on to infinity right here, so positive infinity. So just excluding that vertical asymptote where there are no x values, there's no line there. All right, and then the range, same similar thing, so going from bottom to top, negative infinity, all the way up to that red line, which is at 2. Okay, so we have to stop at 2 because there's no line at 2. We don't touch or cross that. Okay, so then union, 2, and then it goes on forever to infinity. Okay, domain here, going from left to right. So the leftmost point, I actually see an arrow here. So that's negative infinity. The rightmost point is at 1, square bracket, got a point there. Range, lowest to highest, so lowest point is right here at 0. And then the highest, I see an arrow, so that's infinity. All right, that concludes part 1. We will finish these notes in tomorrow's video.